Welcome to Cosmic Quantum Quest. In this video, we are going to explore the mesmerizing life cycle of stars. But before we delve into this celestial odyssey, don't forget to hit that subscribe button to stay tuned for more mind-bending explorations of science. Now, let's ignite the cosmic spark. The life cycle of stars is a fascinating topic that involves the birth, evolution, and death of these luminous objects in the universe. Stars are formed from giant clouds of gas and dust that collapse under their own gravity and start to fuse hydrogen atoms into helium at their cores. This releases a lot of energy and makes the stars shine. Depending on their mass, stars can have different lifetimes and fates. Here is a brief overview of the main stages of stellar evolution. Giant gas cloud. This is the initial stage of a star, where a large cloud of gas and dust, also called a nebula or a molecular cloud, begins to contract due to gravity. The cloud can be hundreds of light years across and contain millions of solar masses of material. The Orion Nebula is an example of a star-forming region in this stage. Protostar. As the gas cloud collapses, it heats up and forms a dense core surrounded by a rotating disk of gas. This is called a protostar, and it is the first step towards becoming a star. The protostar is not yet hot enough to start nuclear fusion, but it emits infrared radiation due to its high temperature. Protostars can be seen with infrared telescopes. T-Tauri Phase. This is a transitional phase between a protostar and a main sequence star. The protostar stops accreting material from the disk and starts to blow away the remaining gas and dust with a strong stellar wind. This creates a cavity around the star, and sometimes a jet of material along its axis. The star also becomes more stable and rotates more slowly. The T-Tauri phase lasts for about 100 million years. Main sequence. This is the longest and most stable phase of a star's life, where it burns hydrogen into helium in its core. The star is in equilibrium between the inward pressure of gravity and the outward pressure of radiation. The star's luminosity, temperature, and size depend on its mass. The Sun is an example of a main sequence star. Red giant. When the star runs out of hydrogen in its core, it starts to fuse hydrogen in a shell around the core. This causes the star to expand and cool down, becoming a red giant. The star's outer layers become more loosely bound and can be stripped away by stellar winds or by a companion star. The star's core contracts and heats up, preparing for the next stage of fusion. The fusion of heavier elements. Depending on the mass of the star, it can fuse heavier elements than helium in its core or in shells around the core. For stars with masses between 1/2 and 8 solar masses, the next stage is the fusion of helium into carbon and oxygen. This produces more energy and makes the star expand and contract in cycles, creating pulsations. The star becomes a red supergiant or an asymptotic giant branch star. For stars with masses above 8 solar masses, the fusion of heavier elements can continue up to iron, which is the most stable element and does not release energy when fused. The star becomes a massive supergiant with a complex structure of layers. Supernovae and planetary nebulae. These are the final stages of a star's life, where it ejects its outer layers and exposes its core. For stars with masses between 1/2 and 8 solar masses, the core becomes a white dwarf, which is a dense remnant of carbon and oxygen. The ejected material forms a planetary nebula, which is a glowing shell of gas and dust. The Cat's Eye Nebula is an example of a planetary nebula. For stars with masses above 8 solar masses, the core collapses into a neutron star or a black hole, which are extremely dense remnants of neutrons or a singularity. The collapse triggers a powerful explosion called a supernova, which can outshine an entire galaxy. The ejected material forms a supernova remnant, which is an expanding cloud of gas and dust. The Crab Nebula is an example of a supernova remnant. I hope this explanation helps you understand the life cycle of stars better. If you'd like to support us, please subscribe and comment your doubts and video suggestions. I will reply. Thank you for watching.